This is Unit 2, Day 6, Part 2, just continuing on here with example 46. So we're going to use the equation that we just got from Part A, that's in point slope form, and right now we are solving or trying to isolate P of C. But before I could do that, we're just going to distribute here what we have over on the right side. So that becomes 0.15x, and then when you multiply 0.15 times that negative 52, you're going to get negative $7.80. Okay? To get P of C by itself, I'm adding 1280 to both sides. And I'm resulting in P of C is equal to 0.15x plus $5. Okay? So what did I just figure out right there? That means every month, that's my monthly fee, I'm getting charged $5, and then I pay 15 cents per call. Okay? So my answer to this is $5. That's my fixed cost. Alright, moving on here. Example 47. This one's a little bit harder, so bear with me. A lot of this is a ton of calculator work, and I apologize for not being able to show you the calculator, but I will try and walk you through it as best I can just by descriptions here, okay? So basically it says you have a factory that produces widgets. The cost C, so total cost C, that's like your Y, in dollars to produce W widgets, which is like your X, is given by the equation, and you guys can read that. It says each widget sells for 26 cents. Thus, the revenue gained R from selling these widgets is given by R equals blah, blah, blah. Okay? So here's your total cost factor equation. Here's your revenue. So we have two separate lines. Treat this like a Y and that like an X, and this like a Y, that like an X. So it wants you to graph it. So part A, using your graphing calculator to sketch and label each of these linear functions for the interval from 0 to 500. Okay, so that's the W, that's your domain. So they want you to go from 0, which is starting here, so maybe go up by hundreds each time. I might be running out of space, so 100, 200, 300, 400, 500. Okay, so there's me going up by hundreds every time. Okay. And then, I don't know, I think I would probably go to 100, because remember that's my C, I'm sorry, that's my total cost C in dollars. That's right, that's like my Y. Okay, and then I would maybe go by tens. So would it be like 10, 20, 30, 40, there's 50, 60, 70, 80, there's 90. Okay, so if you're going to use your graphing calculator, before you put these in, so this is just going to be like, start your graph page, you're going to have f of x equals 0.18x, you can't put W in that calculator, plus 20.64. You hit enter, you're not going to see anything in the picture because it's way off the scale. We'll fix that in a minute. Then you're going to tab it, put in f of 2, and put that in as 0.26W. Again, that one doesn't show. So, a couple things you could do. You can hit menu and you can zoom fit it and it'll pop up on your screen, or change your axes, okay? So what you're going to do is if you hit menu and then somewhere it's going to tell you window, then you go to window settings, okay? You're going to start adjusting it. So you want the X minimum, meaning where you're starting at. You could start at 0. Your X maximum, okay, this is my X, my W, is going to be 500. And then it asks you like the scale, I think it says, what you're going to change it by. Well, we're going by hundreds. Okay, so again, you're in menu. Then it says something about window. And then it says window settings, and we're changing them. So my X min is 0. I'm going from 0 up to 500 by 100. You do the same thing for the y's. So the y min, let's say, is 0. My y max is going to be 100. And I went by tens. So my y scale, I'm going by tens. Okay? Then again, hopefully things pop in. Now, part B says use your, oh, I didn't graph it. But basically what's going to happen is you could use the tables. It's very hard to get this, but you're going to get a little eyeball of this. So the first graph ends up being having a y-intercept just kind of below the 50. And there's that one. Okay? The revenue graph starts a little bit below the 40. And then it kind of intersects right there. Okay, they're very slim, very hard to draw. And again, I just freehanded that really quick, so mine's going to be off a little bit. But now it says part B, use your graphing calculator to find the intersection. You got to know this, okay? It's going to become your best friend. If you click menu, then hit choice 8, which is geometry, then choice 1, which says points and lines, and then choice 3, it says intersection points. The calculator can find the intersection for you. So after you hit menu 813, you click on both graphs. So first click your C graph, which is probably in, I think, blue, and then you click on the red graph, which is your second one. So click both graphs. So it's going to be 2 clicks. Click on one graph, click on the other. Then you hit enter, and your point of intersection should appear. Okay? Your point of intersection should appear, and your point of intersection is going to be the point 258 for the x value. I lost my y. And then the y value is 67.08. I think mine rounded it to 67.1. So it's going to be 258. And I think my calculator said 67.1 or 67.08. Okay. So now be careful. It says using that, determine the number of widgets, W. Remember, W is like your X, okay, that must be produced for the revenue to equal the cost. So the answer is 258 because it's looking for the X value. Okay. Part C, if profit is defined as the revenue minus the cost, write an equation in terms of W for the profit P. Okay. Profit P. Hang on, guys. Okay, sorry about that. My stylus wasn't working. So ready? Profit is equal to, it tells you right here, revenue minus cost. So revenue was R minus cost, which is C. So now just substitute in. Up top here, if you follow my eraser, it says revenue was 0.26 W, but it's minusing the cost. Now you're going to notice I'm going to have to put that whole thing in parentheses. So it's 0.18 W plus 20.64. And if you remember from algebra, this negative has to be distributed, which will change these signs right there, and those both become negative. Okay? When you combine like terms and simplify, you'll get that P is equal to, or P of W, I should say, is equal to 0.08 W minus 20.64. Now, if you're asking where the 0.08 came from, that was 0.26 minus 0.18. It results in 0.08 W. Okay? Using your graphing calculator, sketch a graph of the profit. So it wants me to graph this function over here. Okay? Using a table on your calculator to determine an appropriate window for viewing, then label your x and y axes on the graph. All right, so I went, now remember, the domain, it wants you to go from 0 to 1,000. So this is what I did. If this has to be 1,000, then halfway through is 500. Then half of 500 would be 250. and then a quarter of that would be 750. So there's my labels there. Okay. And then for the y values, just graphing it, I think I went as high as like 50. So then half of 50 would be 25. And then down here would be negative 25. Okay. Using my calculator to graph that. Now look, guys, you have a y-intercept of negative 20. So it ends up being probably right around here. Okay, and then it crosses somewhere like this. And again, I use the graphing calculator to help me there. Okay. It says label the x and y intercepts of this line on the graph. Well, here's my y-intercept right there. And here's my x-intercept right here. Okay. How could you use the table to help you with that? X-intercept is when the y is equal to 0 on your table, and the y-intercept is when the x is equal to 0 on your table. Okay, so for example, for the y-intercept on the table, it's going to say 0, negative 20.64, because that's my y-intercept. Okay, all right, part E. What is the minimum number of widgets that must be sold in order for the profit to reach at least 40? So they're telling you let P be 40. So set the equation equal to 40. So 40 is equal to 0.08W minus 20.64. And you're solving for W. So you could use NSolve, and you're going to get 758. Okay, if you did that graphically, here's the line, like y equals 40. And you're finding the point of intersection, and that point of intersection is at 758. Okay? All right, moving on real quick to example 48. It's our last one here. On the grid below, the linear function of y equals 2x minus 4 is graphed, okay, along with that line y equals x, and they're both labeled there for you. How can you quickly tell that this is a one-to-one function? So as soon as you guys hear the word one-to-one, you need to think, well, it has to pass the horizontal line test. So if I look at anywhere on here, now remember, I'm only paying attention to this line right here, okay? That passes the horizontal line test. Okay, so I know that that function's one-to-one. So I could write it passes the HLT, horizontal line test. Part B, graph the inverse. Now remember, you switch x and y. So take all of these points that they gave you and switch them. So for example, right here, that is the point 2, 0. Reverse that, it's 0, 2. Okay, this right here, the point itself is on the line, that stays on the line. This one is 1, 2, 3, 4, 5. This is 5, 6, so now I have to graph 6, 5, which is going to result 1, 2, 3, 4, right here. Okay, this is the point 1, negative 2, so I have to do negative 2, 1. Okay, here's the point 3, 2, so I have to go 2, 3. Okay, this one is the point 0, negative 1, negative 2, negative 3, negative 4. So that's 0, negative 4. I have to go negative 4, 0. Okay, that should be enough for me to sketch this line. And there's the inverse of that function. Okay, what is so neat about this? Look, guys, this original function and its inverse is a perfect reflection over the line y equals x right down here in the middle. Okay, so part C says, what can be said about those two graphs? Well, they're symmetric. Last part here, find the equation of the inverse in y equals mx plus b form. Remember, you need a slope, you need a b. Well, your b is your y-intercept is going to be 2. Why? Because it's crossing over the x-axis at 2. The slope is up 1 over 2. Up 1 over 2. So that means your slope is positive a half. So the equation, y equals 1/2 x plus 2.